Tom nailed it by having me follow Brad. Could you store a ROA in a blockchain? Yes. Is it a good idea? We'll find out. That's some of the things I'm going to talk about today. Typically, when I'm presenting in these kind of forums, I'm presenting on IP Multicast. I've been working on IP Multicast for 20 plus years. I chair a IETF working group that's PIM, that's Multicast focused. And when I worked at Cisco, I was working in a Multicast development team. Before that, I was working in the TAC, supporting people like yourselves on troubleshooting things like multicast and routing protocols. And I quickly found that that topic is almost as loathed as the topic I'm going to talk about today. Many people just get really frustrated with multicast, and I've just kind of built my career on talking about things that people despise. And this is very passionate, particularly in the IETF. The passions run hot when you talk about things like blockchain. And I remember similar topics on, whether it was SDN or multicast VPNs, there's similar passions of people that just really resisted these kind of things. So is something like a blockchain will help us to further secure, either by supplementing something like RPKI, or maybe replacing it, or maybe there's some other Merkle tree, append-only type of a database that can solve it? Maybe. Let's talk about it. So the thing that does get people at least thinking about this topic is that blockchain is being worked on in standards organizations, and it's even surprising to me, particularly in the IETF. The IETF now has 2 working groups that are working on things related to blockchain. One of them is an interoperability protocol that allows you to interoperate between 2 different blockchains. I'll get into that in a bit. There's another one that's a supply chain related working group that's focusing on a distributed ledger, like a blockchain, to secure supply chains. ITUT also has many specs with regards to blockchain. They recently formed a metaverse focus group, which is naturally using blockchain as the underlying technology for a metaverse. IEEE has many specs, several working groups working on blockchain in regards to IoT, data formats, and governance. And ISO and ANSI and NIST and others are also working on blockchain. So there's a little bit of legitimacy to talking about this. So one of the use cases to at least show that blockchain is not all about just cryptocurrency, which is the main application that is using blockchain, but blockchain is being used in the supply chain to help track that data and to store it in a place where fraud can be prevented. A lot of money is being lost in the supply chain where people are trying to track either their food or whatever it happens to be along the supply chain, whether fraud's occurring, paper transactions get a little bit confusing and lost. That's particularly important when you talk about pharmaceuticals, particularly biopharmaceuticals that need to be maintained at a certain temperature. Typically, biopharmaceuticals need to stay at anywhere from like 2 to 8 degrees Celsius along the supply chain. And if that doesn't happen, then they get ruined, they're wasted. Who's going to pay for that? Where along the supply chain did that occur? Whose insurance is going to cover that? And so there are some companies that are starting to use, and this is why there's a working group in the IETF, that are starting to use something like a blockchain to input the data along the supply chain path to put it in a place where you can't change the data. Everybody knows who put it in there. They know if you've tried to change that data, and you can track it along the path. And so that's just one of the use cases that are being used. It's important to understand that the difference between blockchains and distributed consensus systems. Blockchains themselves really shouldn't be very controversial. They're storing transactions over a distributed state. They help to determine who owns what, provide asset tracing, and securing the digital content. And they do it quite well. Consensus protocols really should be the focus of the controversy and the debate and trying to figure out what to do with those, because these are the protocols that are really the backbones of blockchains. They're validating transactions, they're adding blocks, they're working on state, which is oftentimes inconsistent, and that's the protocol. There are a set of protocols that are putting the data into a blockchain. Proof of work is the one that's most famous. That's what Bitcoin uses. There's a lot of energy that's used by proof of work to provide the security, to put the blocks into a blockchain. That's what most people just despise, and that's why they oftentimes dismiss blockchain. There's many other distributed consensus systems, however, in order to put transactions on a blockchain, including proof of stake. Ethereum is a popular cryptocurrency that runs across the internet. They merged last year from proof of work to proof of stake. It uses 99.98% less energy, much more efficient. They're constantly working on trying to make it more scalable. So that's really the area of focus. And maybe it's an area of focus that maybe we can use within standards organizations. Maybe if this really is something that sticks, maybe it's something that we may want to create our own standards distributed consensus system that's focused on securing networking. You could use a traditional database. That's what's being used today. Databases are controlled by an administrator. They're client server in nature. Malicious actors could alter the data. The administrator either could be compromised, or otherwise the database could be altered. The administrator does decide which data is accessible and visible. They're the ones that decide that. And they're easy to implement, and they're pretty fast and scalable. So they work. So blockchains, on the other hand, are decentralized and allow permissionless participation, which is very attractive in some applications, particularly like with regards to gaming. It's nearly impossible to alter the data. There's a lot of security built into them. There's no central administrator, and they're not particularly fast. They're getting faster. Again, places like solutions like Ethereum are making them more scalable and fast, but they're not as fast as they need to be. It's to be able to kind of visualize, if this is all new to you, what something like a blockchain is. It's really a peer-to-peer application. We sometimes refer to them as overlays, but they're not really overlays because they don't have a routing component. They're applications that consist of, in Bitcoin's network, just millions of nodes, many, many nodes. Nodes that verify transactions, execute smart contracts, which are programs that reside on a blockchain, and they execute when certain conditions exist. There's boot seed nodes to bootstrap new clients. There's to process new blocks. There's full nodes, which are kind of similar to, like in the BGP world, receiving full BGP routes. In this case, they're receiving the entire blockchain from the Genesis block to where it is currently. And then you've got lightweight nodes that are just receiving partial portions of that blockchain, kind of like receiving partial routes. These applications don't really care much about what's going on in the network. They just assume that it works. They have their own network that they secure, and that's what they're worried about. In the IEEE, again, there's several working groups, and one of the working groups that I follow, the IoT working group, this is their layering architecture. This may be different from some other organizations, but the consistent thing is this consensus layer. So you've got at the application layer things like your wallet. DLT is distributed ledger technology. It's just another broader term for what I'm talking about today. That word is oftentimes used interchangeably. The wallet is one that holds a private key. If you lose that, you lose your money. Nobody else has it. And that's where the security compromises exist, typically, is on the application layer. You've got the application protocol layer with identity management and token management. Sometimes you have an oracle. There's a transaction engine and smart contract. And then you get to this consensus layer, which is the most important layer. It's what decides what's going into the blockchain. And then you've got the transactions that are put into blocks. Typically, it's 100 or so transactions that go into these blocks, and then you just build a new block when that's full. And then we're familiar with the lower layer protocols. So what are some IETF and other standards organizations' opportunities? As I mentioned, there's all these different consensus algorithms, proof of work, proof of stake, there's proof of capability, proof of space. There's so many different types of consensus algorithms. It was suggested that maybe the IETF, again, if this is something that progresses, we need to at least look at this as researchers, is something that the IETF should focus on to make it specific to networking. The IETF's already working on interoperability. I'll get into some more detail, time permitting, with the Secure Asset Transfer Protocol Working Group. It's a new working group as of this year. We may be able to use a distributed ledger like a blockchain to integrate with network functions, improve on scalability and costs. Again, I mentioned that some of these standards organizations are working on metaverse. We can maybe improve some things there. Blockchain as a service is what's offered today by cloud providers. Maybe there's something there that we can get involved with. So interoperability. So today, if Alice wants to send something to Bob, if it's money, it'll go through a bank, some sort of a exchange to do that. There is something in the crypto world where you have these cross-chain bridges, which also allow that kind of a interoperability to occur. They're software only, not particularly secure, and actually millions of dollars have been lost by people compromising these cross-chain bridges. So with this new protocol group, working group that they're developing right now, they have the idea of multiple gateways. Those gateways are secure using TLS in the communication and something like RATs, remote attestation for the hardware security. And they're able to provide the opportunity between the interoperability between two networks. And these networks are opaque to the other network. They could be different blockchains. You can have an Ethereum blockchain and a Bitcoin blockchain, which today there's no interoperability. They use totally different systems, but providing that interoperability. So it's a really interesting working group because you have finance people in this working group. You've got networking people in this working group. You've got database and blockchain people working in this intergroup. So it's a pretty fascinating group. If you're interested, I would recommend getting involved. So basically, kind of the way this works, and this is just taken directly from the architecture draft, is you've got an originator and a beneficiary. You've got a unidirectional transfer of an asset between them. There's different stages. In stage 0, the applications inform each other that they want to do this. They work out any sort of a currency conversion that needs to take place because they're different. And then you've got the pre-allocation of asset stage by these gateways, making sure that the assets are there and that everybody's legitimate, making sure that the hardware between the gateways is secure. Then you lock the transaction so there's no double spending that occurs. And then you commit in step 3. We're all in. We're going to make sure that this transaction happens. If there's a collision or a crash, rather, in the process, then you revert. It's a separate protocol. You can revert to where you were before the crash. Another working group, as I mentioned, is a supply chain-related working group focused on integrity, transparency, and trust. It is a working group as of this year as well. And and that's why I shared that use case at the beginning to kind of show what they're doing. And they're in their architecture using a secure ledger. It could be, like I mentioned, it could be a blockchain, it could be any sort of a Merkle tree, append-only type of a database. But it needs to be able to provide the underlying technology for the supply chain security. So what are some other routing opportunities? Again, keep an open mind. Don't just automatically dismiss this. We're just evaluating these things to see if this is something that is useful. If it's not, then we'll go on to something else. So maybe we could use a blockchain to trust packet capture data. You're capturing packet data right now, uploading it to a server. Maybe for whatever reason you don't trust that server, or maybe you want to add additional trust. Maybe that process is potentially risky for really sensitive data. you could upload it to a blockchain instead, and you know it's not going to be compromised. And if you know, you can see who is trying to compromise it. So network management could move to a more decentralized smart contract kind of a base system. You could use a blockchain to sign routing advertisements, maybe even be able to provide proof of transit. I know BGP-SEC is able to provide that. It's had limited success. Maybe this is one way that we can additionally provide proof of transit by, as the packet's going along, upload that data up into a blockchain. And that blockchain can be permissioned, permissionless. It can be very focused on only certain people have access to it. It doesn't have to be wide open like Bitcoin is. And as I mentioned, maybe you can store ROAs in a blockchain. You could also use an overlay. Some of you may be familiar with Lisp, not the programming language, but the routing protocol, locator ID separation protocol. You could use that to, and it is, at least in experiments, being used to find the best peer. These overlays like Lisp are allowing you to take applications and networks and kind of be able to provide interoperability between them too and be able to support applications better. So there's a draft where we're putting all this information that we're gathering into. Particularly, we've named it BGP. It could really be applied to any routing protocol, but we're just reviewing possible opportunities of using a distributed consensus system to secure BGP policies within a domain and maybe across the global internet as well. And really, what it would provide is a single source of truth, something for which DCSs are really well suited, and maybe to complement what was previously discussed. So we could, have, if you wanted to take a look, maybe a visual look at this, you could have a distributed consensus system, either an existing one or a new one created. You could have a BGP blockchain table put into that, not to replace the existing one. We probably want to keep the control plane separate, but just as an additional check, we could put the BGP data in a blockchain and maybe have a smart contract that is able to work in conjunction with that. And maybe if you've received too many prepends, you can initiate a blocking of that update or anything else that you may want to do. So I just took this image off of the Cloudflare website. Probably should have grabbed one from Brad's in the previous presentation, but this just kind of at a high level shows where blockchain or something similar could potentially be used. He mentioned several databases. So you have these RIRs, and they have their databases. Maybe they could use something like a blockchain to store their data. Maybe the validators could also maybe run a partial version of that blockchain, or maybe the full blockchain, and be able to use that as their basis for validating routes. The routers, so that's one option, using blockchain, the validator. The routers themselves, again, probably don't want to be running a blockchain instance, but they could, when you're using your show validation database to see what the current database looks like, it may just be able to pull, maybe from the validator, a copy of what that current validation is, and then use that for its routing decision making. There's also a draft that we are working on, particularly Dirk Trossen and his team in Germany. They've looked at, what is the impact of these technologies, distributed ledger technologies on the network, particularly for operators. Operators are allowing blockchain type ledgers to run over the network. How is it impacting the network? And unfortunately, there's no specs that you can look at to really delve into what's going on with something like Ethereum. And so you have to just look at the code. It's pretty tedious to kind of find out what's going on. But again, just to remind us why this is happening is that the DLTs, they don't really care about the network, but the network wants to find out what's going on, in terms of costs and traffic generated. So again, this work is to try to understand the impacts and the opportunities to potentially improve on those impacts. So there's several interactions that are happening that it's important to kind of just understand. Is like, the client's committing a transaction request to this cloud of miners that are out there. The miner commits a found block to the DLT after it discovers what this mathematical calculation is. It lets all the other miners know that it solved it, and then it's allowed to put the data into the block. A client or miner can read the blockchain in the DLT. I'm going to kind of skip through quickly because we're kind of running out of time here. It's important to try and understand the communication patterns. There's a lot of communication that's going on between these peers. Again, there's millions of peers in something that's broad as a Bitcoin over the global internet. For node discovery, and we found that there's a lot of wasted communication that's going on between trying to find peers, never getting a response, having to start over again, finding IP addresses of the miners and other nodes, and it can be a little bit tedious. So the challenges are kind of just outlined here. Again, as I mentioned, there's just, we need to contact a potential peer, wait for connections, inquire about capabilities, and disconnect if not matching. Unicast is used. I can't help but putting in just a little bit of multicast in this presentation just because I can't help myself. But so we're going to just share a little slide on that. But Unicast is used, so maybe we can use multicast to help them improve their application, maybe. Last slide. Yeah, before the summary. So using multicast for DLT. So currently, it doesn't seem like it would be very useful. It's very highly dynamic. The pools are constantly changing, the peers are constantly changing. They do that for security reasons and for fairness reasons. And multicast likes a bit of stability in its trees, and so it's very hard. It's also very highly distributed. You don't know the nodes across the world that you're finding, and global multicast is not something that's fully supported. And, again, very highly diverse peers. So let me just get to the summary. A lot of information that I've shared here. So blockchain is the backbone for crypto assets. And you may or may not like crypto. It's being worked on today. Banks are trying to figure out what to do with it. It's likely not going away. But there's many other use cases, including supply chains, where we can use this technology potentially, and maybe even in routing. So there are some potential opportunities for using something like a blockchain and networking. I've identified some of them, maybe a networking distributed consensus system, a private blockchain to secure data, either supplement or replace the RIR database. Probably won't be replacing the database. Probably going to be supplementing them. Interoperability, scalability, multicast maybe, and supply chain integrity. So, and additionally, as I just kind of quickly went through, DLTs do have a clear impact on provider networks. We're trying to figure out how much of that impact is, all these TCP and sometimes UDP connections. How is that impacting my network? We've presented this work in the IETF. We've had many side meetings. We've written many IEEE papers. If you're interested in this, please reach out to me, reach out, join that list, and we're happy to work with you. We're very interested to work with you. Thank you very much.